Okay, now we're going to solve some problems using gravity as the acceleration due to gravity. You'll notice that our equation looks a little different, right? It's still Newton's second law, but this is a special case where acceleration is a constant, right? G is the acceleration due to gravity. We've talked about that a little bit, okay? And it's always this number here. Oops. Let's try and actually highlight that instead of drawing a line through it. We're going to use 10 meters per second squared. It's not as precise, it's not as accurate, but it really helps us do math pretty easy. So we're going to use 10 meters per second to get a general estimate, right, of how much force there is. Okay, here we go. A 150 gram experiences gravity. A 150 gram, okay, 150 grams experiences gravity and falls towards Earth. Determine the force of gravity acting on the apple. Oh, it's an apple, that's 150 grams. Here we go. We're gonna use our equation. Fg is equal to m times g. Now remember, I'm gonna use orange here, grams, right? In physics, we tend to like to convert, right? So 150 grams is equal to 0.150 kilograms. Remember, I'm just moving the decimal 3 to the left because a kilogram is big, so I have to make my number small. Okay, we're going to use 0.150 kilograms. Okay, so here we go. This is equal to 0.150 kilograms times, we're going to use our gravity, meters per second squared, 10 meters per second squared. When I do this, whoopsie, I end up with 1.5. This is kilogram meters per second squared. It's also known as a Newton. So I can just write Newton. Remember, forces also have direction. Okay, they are vectors, so 1.5 newtons down. All right, that's pretty easy. You should be able to figure out those equations fairly easily. When an object is in free fall, it does not necessarily accelerate toward the ground for its entire trip. Look. Here we go, gravity, look. Notice gravity has the same force all the way down, right? This 833 newtons, but there's this thing called air resistance. Notice it's F air. You could also say that that's FD for drag. It increases over time because it has to do with some speed, okay? How fast you're going. All right, when an object is done, if air resistance is large enough, the downward force of gravity will balance the upward force of air resistance. When this happens, the object no longer accelerates toward the ground, instead moving at a constant velocity. Remember, if it's constant velocity, acceleration is 0. If acceleration is 0, that means, right, F net is also 0. This is called terminal velocity. I don't know if you guys have heard that term before, right? Lots of times it's like, we don't want you to reach terminal velocity, or it's reached terminal velocity, that's terrible. I mean, it is, because it means you're going as fast as you can, and right, and it's hard to slow it down. But it's not like, oh, it's going to kill you to be falling at this speed, right? Terminal velocity is just a technical term that means that is the absolute fastest, right, that you can fall from a plane, from right in the sky. Okay, draw the free body diagram, then find the acceleration. Okay, here we go. I'm going to draw my dot. Skydiver, so he has two forces acting on him. One force is going to be down, right? That would be Fg, right? That's gravity. Then there is the upward force, right, of air resistance. Now they did it as F air, so I'll just do it as F air. Remember, F air is the same as FD. Drag and air resistance are the same, okay? Drag is equal to air resistance. They're the same thing. It's basically that the molecules of the air are colliding, right, and slowing your speed down. Okay, so what we have to find, notice it says find the acceleration. Find the acceleration. So eventually we will have to solve this equation, which we'll get to. I know I have two forces, so I need the sum of the forces, also known as F net, is equal to M times A, right? What we're solving for is A. I know that there is this mass. Luckily, it's in kilograms for us. I like that. I do have to find, oh, look, okay, I got it. Here's my air resistance force, right? That's in newtons. Oh, yeah, that's in newtons. So I know that this is equal to 115 newtons, okay? I don't know what Fg is equal to, but I can figure it out. Fg is equal to M times G, right? M times G, which is equal to, the mass is 65 kilograms, right, from above. And I know G is 10 meters per second squared. There we go. This means Fg is equal to 650 newtons, right? I can just say that, newtons. Now, because these are opposite, right, I can solve my F net equation, right? The sum of my forces is equal to F air, he's going up, so he's positive, right, plus Fg. F air is 115 newtons plus, remember, Fg is down. I should maybe write that. Here we go. Fg is down, right? And I know F air is up. So up is positive. That's that. 115. That means this is negative 650 newtons. Oh, I'm going to run into my free body diagram. So this is negative 535 newtons. Remember, this negative just means down. Okay, it just tells me the direction. So now I can take this number here, right? This 535, and I'm going to put it over here. 535, I got to make it negative, newtons, is equal to my mass, 65 kilograms, times acceleration. Now I just use algebra, the power of algebra, kilograms. So my acceleration ends up being negative, oh, put it in my calculator. Sorry, give me a minute. Put it in my calculator. Oh, there we go. Negative 8.23. Its acceleration, my units are meters per second squared. Okay. It's negative, so I could say 8.23 meters per second down. Both of those options are the same. Just make sure you don't do like negative 8.23 meters per second down, right? That's just being redundant. This is my answer here. Okay. When we talk about terminal velocity, remember terminal velocity means F net is 0. So if I use my equation, F net is equal to mass times acceleration, I know terminal velocity is equal to constant velocity. And if it's constant velocity, we know that acceleration is 0. We can show that by saying 0 newtons is equal to 65 kilograms times acceleration, right? If we divide by 65, and we divide by 65, we know 0 divided by anything, acceleration is 0, right? 0 meters per second. You guys, that box is terrible. Okay, I hope this gives you enough information to do the practice problems. Good luck.